Hey everybody, we are back for our last video of the week, combinations. So, definition, a combination is a selection of R objects from a group of N objects where order is not important. So combinations are similar to permutations, but the big difference is order does not matter with combinations. So, for example, if we look at my first example there, in the last video, we did permutations of the letters ABC, right? And we found that there were 6 permutations. I'm going to put 6 perms. 6 permutations of the letters ABC. Well, how many combinations do we have of those letters? And this is kind of a trick question, but I did this to illustrate the point that with combinations, order doesn't matter. So like ABC, BAC, we had what? CAB, and there was other ones, blah, blah, blah. There were 6 of them. The thing with combinations is ABC is not any different from BAC, and that's not any different from CAB. Order doesn't matter with combinations. What matters is just the grouping itself, that you have the A, you have the B, and you have the C somewhere. So really, there's only one way, one possible combination for ABC. So, basically, again, we're just kind of thinking of it like a permutation, but then we're not accounting for order. We don't care about the order. So let's look at number 2. Your English teacher has asked you to select 3 novels from a list of 10 to read as an independent project. And how many ways can you choose which books to read? So first, let's just talk about this problem and how do you know it's a combination problem? Because when you guys do the homework, it's not going to always tell you. This is a permutation, use the permutation formula. This is a combination, use the combination formula. So you have to be able to figure it out. And it's all about order. You want to ask the question to yourself, does order matter here? And I mean, if you think about it, you could read those books in a certain order, but that's not what they're asking. They're not asking about the order in which you read the books. In how many ways can you choose which books to read? So it doesn't matter which book you pick first, which book you pick second, which book you pick third. You picked the same 3 books. So order does not matter here. In the last problems, in the last video, order mattered. Placing first, second, and third, order definitely matters there, right? But picking a group of, the 3 books you want to read for an independent project, order doesn't matter. You're going to read the same books no matter what. So, how can we figure out this value? So there's 2 ways we can approach this. I'm going to start with the, picture way. How can we use a picture to figure this out? And then there's a formula, of course, which is all the way down here, and we'll talk about that in a minute. So the picture way. So let's start with figuring out how many options we have for these books, right? So on top, because we're going to have a fraction of some kind. So for my first book, we have 10 choices, right? That's for book 1. 10 different choices. Well, once you pick that book, how many books do you have left to pick from your second book? There's 9. Third book, 8. So it's your first book, your second book, your third book. And we stop there because we were only picking out 3 books out of the 10. But again, order does not matter here. So you might have picked one of these books first, but that's no different from picking another book first, right? It's just what matters is the 3 books you choose, not the order in which you choose them. So what we have to do is we divide by the number of objects you chose. We chose 3, and then make that a factorial. If we had only chosen 2 books, we would have like 10 times 9, and then we would divide by 2 factorial. So we divide by the number of objects we chose. So you can simplify this. This is, 10 times 9 times 8, all over 3 times 2 times 1. You can do some cancellation. However you want to do it, you can multiply the top, multiply the bottom, and then do the division. No matter what, you should end up with the answer of 120. There's 120 different ways for you to just pick out 3 books from those 10, with order not mattering. Now there's a formula. Let's go ahead and look at the formula, which I have down here. So let me rewrite it. NCR, because C for combination. We use P for permutation, C for combination. And then on the bottom, so it's equal to n factorial over r factorial times n minus r factorial. So there's a little bit more work involved in this one. Let's apply this problem to it. So n and r are the same thing that they were in the permutation formula. So n is your total number of objects. So like in this case, there was 10 books to pick from. And R is the number you're choosing. How many of those books are we choosing? So let's apply it. Our N was equal to 10, and our R was 3. We were choosing 3 of those books out of all 10. So using the formula, we get 10C3. We read this usually as 10 choose 3. We're choosing 3 out of the 10. And we'll have 10 factorial all over r factorial, which was 3, times n minus r factorial. So 10 minus 3 factorial. Okay. Let's simplify. We got 10 factorial on top, 3 factorial on the bottom. 10 minus 3 is 7 factorial. And we can work this out. 10 times 9 times 8 times 7 factorial. I'm going to leave that as 7 factorial because that will cancel with the bottom. Boom, boom. And then look, 10 times 9 times 8 divided by 3 factorial. That's what I had over here. Ooh. I don't know if you guys can see that, but like I wrote it and then it kept... Okay. There we go. It's fixed. Anyway. So, yeah, we end up with the same thing. 10 times 9 times 8 divided by 3 factorial. So once again, you have options. Sometimes you can draw this picture out, or you can use the formula.